Hi, Colin. Many thanks for your lovely invitation. I'm here to talk about the optimization microwave heating for carbon epoxy pre-curing using AI-driven control systems. Also here we can mention that about the enhancing efficiency and about the sustainability in advanced composite manufacturing. Again, thank you for your invitation to your technical conference, Advanced Functional Materials in Guilin, China. Thank you so much for your invitation. Here you will see my name. My name is Elias Randjbaran. I'm Educational and Training Manager of Aircraft Composite Incorporation, Kuala Malaysia, and I'm graduated from UPM, University Putra Malaysia, one of the highest ranking university in the world. And you will see my publication, also my experience. Here in this presentation, divided into 9 sections and technically 10 sections. Section 1, Introduction and Background. Section 2, about the microwave heating mechanics, AI-driven control system, system integration, experimental methodology, resultant analysis, challenges and solutions, future directions, industrial implication, and also the important part, the last part, is Q&A, question and answer. Hopefully you will send your messages, question, and definitely I will find a good answer for you. Then further after that, we will have a really discussion together, constructive discussion. In section 1, we are going to talk about the composites in modern industries. You know the history of composite back to many years ago, maybe ages. Nowadays in advanced usage, using in aerospace, automotive, renewable energy, and also we know that once we are going to renewable energy, we are going for the important part is sustainable materials. We use the composite, and the advancement of the carbon into it. We will see the strength to weight, and also the corrosion resistance. It means we will find a strong in terms of the resistance against some tensile, and perhaps we can use it also for the impact resistance. If we add the carbon, we will see that compared with the lightweight. Challenges in conventional autoclave curing. We will have it for the intensity from 300 to 500, and as well for the scrap rates from 10 to 15 due to the curing defects. So we are going to improve the curing part. Improving the curing can be really vital and really for every university, every firm, every composite industry. It could be really one of the challenges, and we are facing this challenge in the civilized way and with a really comprehensive way. We are going for that. Microwave heating fundamentals, volumetric heating versus the conductive heating transfer mechanisms. Yeah, we are going to, for each part of it, about the volumetric versus this. Yeah, we are going to, for the microwave heating, we are going to face it. For that part, if we put it in the autoclave, once we put it, we will see from out to in, it means the heat transfer. But from this part, we are going for the microwave, it is out to in. Sorry, from in to out. Yeah, it means from inside the specimen to out. Yeah, totally different. The benefit can be perhaps we will see the half of the faster, between 40 to 60. The average can be 50, half, can be faster, and reduce the energy consumption. That's why I told you we are going to something sustainable. And there are some real examples. We will see that for Airbus A350 component curing. Yeah, they use it. Autoclave, energy cost 220 pounds per part. It means can be the huge one. For the microwave, we will see the 50 of this. Really, we will see the something. Try to reduce the cost as well. And for the current scrap loss, we will see 1.2 million pounds annually. Yeah, it means could be really huge. The problem statement is that I told you non-uniform heating, thermal runaway, and also the dielectric property variability. Yeah, so here it is the problem I told you. We have it we use it for the conventional, or perhaps we use it in the traditional autoclave. Then now we are going to the autoclave, but with the microwave, it could be something different. In the objective of this research, we are going to develop it and adapt the AI control for the perception of it, or we are going to see the something precise. Yeah, microwave material interaction. You have the frequency you will see 2.45 to 5.8 gigahertz in carbon epoxy. Yeah, it could be really good, and we will lose something, and we are going to see this something good. The challenges is the edge effect. You will see the edge of it, some edge of that got problem, and also for the shielding, the carbon fiber got some shielding. Yeah, it could be some mechanism of that. It could be some challenging for us as well. We are going to solve this problem also. Another part we will see for thermal runaway mechanisms. Yeah, positive feedbacks in the loop. We will see the temperature going up. It means the less energy also. The electric also loss going up. Absorption also can be better and can improve. Consequences, the resin degradation, also the void formation can be about 3%. We will see that for 3% as well. We have some limitations as well for the system, for the fixed power we will have, for the sensors as well, for the IR with thermography, we will have some really limitations for this, the manual power cycling. It could be some of challenging we are going to see. Another part for the AI advanced manufacturing. Nowadays, we will see that everything really based on AI. Not only some people really use AI for messaging, AI for writing, or AI for something. We are going for use the AI in a real industry as well to solve a problem, to avoid some repetition, and to increase our reputation. For that one, machine learning can be the advanced. We are going to repeat it a lot. Once we collect a lot of data, huge amount of data, then we can train this machine as a machine learning. Then we can use it AI with high accuracy. Neural network as well, that's really conventional, and we will find it perhaps in maybe 20 years papers. For that one, can be really recommended. Real-time AI applications in composites. The company of Siemens Aerospace also used the AI to optimize the autoclave cycles up to 22%. It means really huge, of more than 20% energy reduction. Hexel as well, for that one user for the void or something like this, really got a reduction. It means it can be a good result for the sensors. Case study of that one, yeah, we can go for that, use the digital twin integration. That is really functional, user console. It was really helpful software. Also here we will see the reduce some really hotspot as if we are going to use the RL algorithm, reduce the hotspot by huge amount, about 70%, 65%, and the scrap, really we are going to reduce the scrap, even come to the 0.5%. It means nothing, half a 1%. Wow, it's really amazing. Reinforcement learning framework, state, space, the temperature, the electric data, the consequences can be the action, and the action also go for the power frequency adjustment, reward functioning, and that is really functional, and also for the gradients to maximize to uniformity. Yeah, it means we will find the surface really uniform. Sensor data fusion, Prepreg, gritting arrays, and also we will see some function for the imaging. For the imaging as well, we will see some functionals. NVIDIA, we could find it through the new generation of computers, laptops. We can use that to reduce the latency, Reducing the latencies is very important. Also, it can be good and functional for term of reusing as some things like a real time. Here we will see the edge AI deployment. Yeah, very good. Another part here, we could see that for the closed loop of architecture. For hardware configuration, 5.8 gigahertz solid state generators, we use that. and it could be nice sensor and really applicable. Also for the industrial IoT integration, nowadays use it real-time data streaming to cloud analysis. We use that. And important is for the materials and specimens about the direction of it, how we can use the direction. 090, it's recommended to use for the laminates. How we can find the laminates, we see the standards, even the part of it for 300 millimeter by 300 millimeter. We use that one. It means it could be the large scale as well. And industrial scale validation, GKN aerospace collaboration, they use that part. We will see the length and also the thickness according to the scale in the aerospace. We will see it could be the huge, and also the thickness. We will see that we are using the something tiny as well. And scale effort and the production in the field of deployment really can be beneficial, and we will see the something we can use the advantages as well. Test matrix, the 3 methods. Autoclave, we will see as a reference, we can go for it. The fixed power microwave, AI controlled microwave. For the autoclave, okay, that is the reference. We are going for it as a benchmark. Then we can see the fixed power microwave. And by AI controlled, we can use the AI controlled once we achieve good information, good result, good data by the sensors. Especially we can use the flat sensors. It can be beneficial for this case. Performance metrics for the temperature really can be less than 5 Celsius degrees of QFTIR. We will see that for radiation, and void content for the micro. And this would be really amazing result for the performance of it. The training, the protocol, you will see the AI training control. I told you, for that one. We should go for the ANSYS software, the physical validation. We can go for it for the transferring learning. I told you, once we collect the data, validated data, we can go for machine learning as well. The thermal uniformity, by employing the method I told you, we can go for the thermal as well uniformity. You will say the thermal can be the difference only 3.2 Celsius degrees to 11.7 Celsius degrees. It can be the really beneficial. It can be really good efficiency and effective in our work. Cure, how we can use for the curing, we will see. Also the AI, and we use the control, you will see that employing the AI, how much the difference we will see. As well for the terms of the void content, we will see 0.3% means nothing. It's amazing. If we calculated easy calculation, perhaps can good maybe for 9 times better than the previous one. You will see here for the energy efficiency, give us the around really 50%, 48%. You can be the 50%, and really for another part can be really effective. Production monitoring dashboard for the real time, even for the controlling, perhaps by the mobile phone application, you can control it and you can monitor it. And you can observe the data from that part. You will see, just in for the BAE case, we will see achieved it in the maybe about the quarter, or maybe for 14 minutes only. We will see for the power adjustment. It means excellent. For another part, we will see that for the mechanical performance, once we are going for that, 87 megapascal versus 70 fixed power, we will see the improvement, at least more than 12%. We will see the improvement. Really, we are going for something that increasing the stiffness and stiffener of the result. Here we will see by the temperature as well. Also, here we see for the gradients, it could be really beneficial. For that part, also we will see the validation, the result. We will see the p-value according to the statistical data. We will see the p-value is excellent. We achieved a good result. For challenges and solutions, still under progress. Once we are working, we will see the number of challenges, and we are going to find a solution. Then we are going to see the development of it. For example, for this is a generative some points, and for a synthetic as well training data, we will see. I told you by repeating the test, we will see some better results, better achievements. EMI, also the interference, can be good, and the solution can be, I told you the fiber optic can be good. And I suggest for that case, the flat fiber optic sensors. It is my personal suggestion. It is out of this research. For that, another part, we are going to adaptation of the university or so the lab scale to the adaptation of it to the industrial. We can go for that for a RL. We can also for digital twin. Nowadays we are using the 5G. Next year maybe we are going to use the 6G. We are going to improve the digital twin as well. For the in the future, we are going for the hybrid heating system, microwave plus RF. It could be for future, and also the thickness. Also, it can be good for the 3D printing. For the 3D printing as well, can be recommended. I told you for the something sustainable, life cycle analysis, about 50%, half of it for the reduction of the footprint in the world, more than 50, 55, compare with the autoclave. For that one, we are going for the manufacturing platform. For that part, we can go for the chaining and also the secure knowledge sharing. We can achieve that part for that part. And another thing, the stakeholder looking for it for the economic impact. Stakeholder and also people investing, they are looking for it. We should respect them. They are preparing us money. Economic impact, we will see that part. Really, we will see the cashback and the money back. The payback for that part, 3.3 years. We will see that. The scrap reduction as well. For the case, we will see that for the Rolls-Royce trial going for it, maybe 28% faster cycle, and also the saving per line. We will see that the huge amount of number for Rolls-Royce, it is 410,000 per year sterling pounds they are going to save. For concluding remark, we will see some achievement for AI. We are using AI to use something precise, 70 to 80% thermal gradient reducing, valuable alternative to autoclave complex component. For the future, we are going to see the part like how to make it standard, full-scale production development. Before we are going to the last section, it means the Q&A, gonna add something to you. It is the pilot study, and it can be the review of something, because due to the shape of each component, once we put it into the microwave oven or microwave for the curing, I told you the edge of it could show the different behavior and different gradients of thermal. We are studying for that part, and hopefully by help of you, we are going to develop it in a better way. So after that, are waiting for your questions, and hopefully I will receive it. Thank you so much for this time for me. And now that's a Q&A. Again, thank you so much, Shani. Thanks.